Good day. Today we're going to discuss how to use MegaStat in Microsoft Excel in determining the correlation between two variables in which the variables has no indicators. Okay, let's say that the study being conducted has a title Self-Esteem and Mathematics Performance of Grade 10 Students. Below, we have the conceptual framework stating that the self-esteem, which is the independent variable, affects the mathematics performance, which is our dependent variable. In our conceptual framework, as we can see here, there is no indicator in every variable. Now, let's state the research objectives. So, the first research objective is that we are going to describe the level of self esteem of grade 10 students. And then we have also to describe the level of mathematics performance of grade 10 students. And then we are going to determine the significant relationship between the self esteem and the mathematics performance of grade 10 students. And then lastly, we are going to determine the model best describes the relationship between the self-esteem and the mathematics performance of grade 10 students. Okay, let's try to continue. Let's say we already have the data of the self-esteem and the mathematics performance. So here we have the data. There are 30 students, okay, under the investigation, and we have the mathematics performance of that students. Now, how we're going to use the MegaStat? In some programs in the MegaStat, you can see here add-ins. And then if you're going to click the add-ins, you can see the MegaStat. In my version, the MegaStat is under the data. We have here the MegaStat. But if you're going to click the MegaStat, you have the same environment. We have the same prompts that you can see. So let's have analyzed the problem or the investigation using the MegaStat. So you have here click MegaStat, and first we're going to have the descriptive statistics, and then you can check whatever you want here, okay, as long as it has relevance to the study or to the investigation. So in this case, I am going to deselect the variance and the standard deviation, the minimum and the maximum range, but I'm going to click the confidence interval since the confidence interval is already included in the statistics and probability topics in your grade 11. Okay, click the input range and then highlight the data that you're going to analyze. So do not include the words, only the data that you're going to select. Then click OK. Okay. After a few while, you have here automatic. You can see another tab in the same sheet. So here we have the output tab. So we have the descriptive statistics. So there are 30 students, as I said. And then the self-esteem has the mean of 19.9. Okay. While the mathematics performance, we have 82.2. And then we have the confidence interval. In the lower boundary, we have the 18.42. And then we have the 21.28 as upper boundary for the self-esteem, while the mathematics performance, we have the lower boundary of 78.9 to 85.5. We have here the margin of error is 1.48 for the self-esteem, and the mathematics performance is 3.30. Okay. Now, let's go back to our sheet. So the research objective number 1 and research objective number 2 stated that we're going to describe the level. So since the where there is described, then we are going to use the descriptive statistics. For the third research objective, which is determining the significant relationship, since we are going to deal the significant relationship, then that is inferential statistics. So here we have to click MegaStat, and then we have correlation regression. Okay, click correlation regression and then correlation matrix. So we are going to highlight and click OK. Okay, in the input range, we have the correlation matrix. Okay, so the correlation matrix, we have self-esteem versus mathematics performance has a R coefficient of 0.935. Now, as we can see here, the cell is highlighted with a golden yellow, okay, a dark yellow color. Okay, this means that the R, which is 0.935, is statistically significant at 0.01. Okay, and if the cell in the correlation matrix has this light yellow highlight, that means it is significant at alpha equals 0.05 level of significance. Now, if the results in the correlation matrix has no highlight, meaning it's not yellow or light yellow, it's just white. If the cells here are white, that means it's not significant at 0.05 or 0.01 level of significance. Okay, now if the color of the font here is black, this means that there is a positive linear relationship. That means as x increases, y also increases, or as x decreases, the y decreases in the person product moment correlation coefficient. Now, if the color of the font here is red, that means that the relationship is negative. It means that as x increases, y decreases, or as x decreases, y decreases. Here, in our example, the color of the font is black. That means there is a positive relationship. It means that as x increases, y also increases. Now, since we have here a golden yellow or dark yellow highlight, this means that it is significant at 0.01. Remember that if the relationship is significant at 0.01, it also means it is significant at 0.05. Remember that in our discussion in the research, we are going to base our significance at 5% level of significance, or 0.05. The alpha is 0.05. So this means that there is a significant relationship between self-esteem and the mathematics performance. Now, since they are related to each other, we are going to get the model. Okay, to get the model of the self-esteem and the mathematics performance, we are going to get the MegaStat, and then correlation regression, and then regression. Okay, the independent variable here is a self-esteem because we're going to predict the mathematics performance based on their self-esteems toward the subject. So we are going to click the independent variable and then highlight, and then click the dependent variable here, and then the mathematics performance. Highlight that one. Click OK. Okay, it's Okay, it's just okay. Okay, so this would be the regression analysis. So here, the p-value of our f is 3.72 e negative 14. This means that uh, it's just a scientific notation. So that is equivalent to 3.72 times 10 raised to the power of negative 14. Therefore, there is 13 zeros before 3, okay, after the decimal point. So that is 0.000000, that is 13 times, and then 372. So this means that it is very close to 0, okay, the p-value. So here we can see that the coefficient of the regression of our self-esteem is 2.089, which is significant. Therefore, it is predictor. The self-esteem is a great predictor to the mathematics performance. Now, how we are going to translate these results in our manuscript. So in our manuscript. Now, remember in our research objective number 1 to describe the level of self-esteem in grade 10 students, meaning we're going to get the mean of the self-esteem, and then we are going to compare the mean to our parameters in the self-esteem. So for the parameters, we have this one. So the parameters we have, if the mean is 1 to 6, that means very low. And then 6 to 01, 6.01 to 12, that is low, and so on. Now we are going to compare our mean to the parameters for the self-esteem. So how are you going to make a table? For the table, okay, so we have the table that is for the mean, okay, for the variable, the mean, and the level. In this case, we only have one. We have 3 by 2. Okay, it must be in the center, and then here it's not bold, and same center. So this is the independent variable. This is the mean and the level. So for our table 1, the mean, I forgot the confidence interval. So the variable L self-esteem. The mean, as you can see here, the mean is 19.9. So that is 19.9. 90. The level for the 19.0, that's false for high. So high. And the confidence interval, we have 18.42 to 21.38. Para hindi ako mawala. So just something like this. So we have 18.42 to 21.38. So this means that within this interval, we can get the true population mean. Remember that the 19.9 is just a sample mean, and we have not yet computed the population mean. So this means that within this interval, uh, at 95% confidence interval, we can say that the population mean is within this interval. And the 19.9 is within this interval. This means it could be that the 19.9 is a true representative of our population mean. Okay, next table, since table 1 will answer the research objective 1, the self-esteem, and then objective number 2, mathematics performance, we are going to make another table for our dependent variable rather. So insert table. So we have 4 by 2. This must be, okay, bold center, and this is unbold. So dependent variable, and then the mean, level, and the confidence interval. Confidence interval. Let's make this one. Okay. Alignment must be at the center. And then we have mathematics performance. The mean is 82.20. The level, so for the level, we are going to get another we are going to refer the mean to another parameters. So for the mathematics performance, we are going to base the mathematics performance to the usual to depth order number 8, which is the usual way of interpreting our grades. So we have, since it is 82.2, so belongs to 80 to 84, which is satisfactory. So the student at this level has developed the fundamental knowledge, skills, and core understandings, and with little guidance with the teacher and or with some assistance from peers, can transfer this understanding through authentic performance tasks, so which is satisfactory. So this is satisfactory. And then the confidence interval is 78.9 to 85.5. 78.9 to 85.5. So we already have answered the objective number 2 and objective number 1. Now, let's have the significant relationship between self-esteem and the mathematics performance. Okay. Okay, the variable, we have the dependent and independent. The variable, we have the mean, the R, the interpretation of the R, okay, and then this one. This is, okay, good. This is not bold, and then let's have the alignment must be at the center. So the variables, and then we have the mean, the R value or the R coefficient, and oops, it must be small letter, and the interpretation. Okay, so the variables are self-esteem, and the mathematics performance. The mean of self-esteem is 19.90. And for the mathematics performance, we have 82.20. And then let's delete the lines between these. Okay, so the R is 0.935. 0.935. Let's put two asterisks there. Later on, I will discuss what does it mean. Now, the R value interpretation, we already discussed this one. Since it is 0.935, that means very high, very, very positive linear relationship. Okay, so let's put some legend here. The two asterisks stands for it is significant at alpha 0.05. Okay, so let's try to discuss the table. So here, the focus of this table is to answer the research objective number 3, which is to determine the significant relationship between the self-esteem and the mathematics performance of grade 10 students. So based in our MegaStat results, the R value here is 0.935 with two asterisks. That means that it is significant at 0.05. Now, if you're wondering why we don't have p-value here, that is the restriction of the MegaStat, the downfall. In the correlation matrix, the MegaStat will not give the p-value. But as we can see here, if we go back to the results, the MegaStat do not give the p-value, but it will tell you, the MegaStat will tell you whether the R is significant at 0.05 or 0.01 by highlighting the cell. So that is the disadvantage of using MegaStat. Because if you are going to use the SPSS, SPSS will give you the p-value of the correlation. Okay, in MegaStat, the MegaStat will not give you the R, not the R, the p-value. Okay, so that's why we have a symbol to asterisk here to say that this R value is significant at 0.05. Now, let's have number 4. Okay, since the self-esteem and mathematics performance are significant, they have this significant relationship, then we can proceed to number 4, the model. Now, if the variables are not significant with each other, we are going to discard number 4 objective. Okay, I'll repeat. If the variables are in significant relationship, they have significant relationship, then we are going to proceed number 4. However, if the variables has no significant relationship, therefore we are going to accept our null hypothesis. Okay, if we are going to accept our null hypothesis here, then we're not going to proceed number 4. Okay, the two asterisks here stands or means that we are going to reject the null hypothesis. Okay, so for our table number 4, so we have the independent variables. Independent variable, we have the dependent rather. Okay, then we have the coefficient. And then we have the R squared, the p-value. Okay. This must be at the center, and it is bold. Here it must be center. The alignment must be center. We have the variables. The coefficient, the p-value, and R squared. Must be small letter. So here our variable, okay, we have self-esteem. And since we are going to have a model, which is a linear model, we have the constant. Okay, constant here is actually the y-intercept of the linear model. So later on, I will let you to see what is the model visually. So here we have the coefficient of the self-esteem is 2.9 2.09 with a p-value of 0.00. Okay, and then the constant, we have 40.62. Okay, their R squared is 0.87. 0.875. Let's try to delete line. Okay. Okay, what does it mean? It means that the self-esteem, okay, since in our table number 3, they have significant relationship, positive significant relationship. This means that the self-esteem affects the mathematics performance by 2.09. This means that the mathematics performance will increase by 1 unit if the self-esteem will increase by 2.09 units, provided that all other variables or other factors will hold constant. Okay, so technically we can create a linear model or linear equation. The linear equation here is the mathematics performance is actually 2.09 times the self-esteem plus 40.62. Okay, so our model is this one. The mathematics performance equals 2.09 times the self-esteem score plus 40.62. Now, R squared here, okay, will tell us, okay, we can visualize that 87.5% of our data is explained by the model. The other percent is actually affected by other factors. So only 87.5% of the data is being explained by our model. Now, what does this model looks like? Now, if we go back to our MegaStat, okay, MegaStat, and then we have the scatter plot, our horizontal axis, which is the dependent variable. Okay, our dependent variable, which is the mathematics performance, and the vertical axis are wrong. The horizontal axis must be the self-esteem. Okay, and the vertical is our independent. Am I wrong? The horizontal axis would be the the dependent variable, which is the x-axis. Our x must be the self-esteem, and then the vertical, which is our y-axis. Okay. So this is what I am talking about. Okay, the line here is our model, the linear model. And the equation of that line is this one. Y equals 2.089 times x plus 40.622. This is our regression model. Y is our mathematics performance. So the mathematics performance can be predicted, okay, with the equation 2.089 or 2.09 times the self-esteem plus 40.62. Okay, so that is how we're going to use the MegaStat, okay, in getting the relationship of two variables if there are no indicators. So thank you.